But those that do, I mean, if we test the meat, for example, for, a handful of minerals or vitamins, selenium levels might be the same. Oh, it's equivalent, it must be perfectly fine. No, actually, that really isn't a way to test safety at all. And we've talked about, well, the known health risks in cloned meat. I mean, the process itself lends itself to genetic damage, to genetic defects, and you can't predict where those genetic defects are going to be. You see through what we already know that cloned animals are prone to have a lot of organ damage. So the genetic defects affect their organs, but you can't really predict. Well, how do you predict then what the danger from a process that is prone to creating genetic defects are going to be with humans that consume it? I mean, we know just using genetically modified corn that it's genetically modified to produce an insecticide called Bt toxin. Well, we've learned that when humans eat Bt corn, that the bacteria in our digestive tract can assume that genetic programming in the corn and start making Bt toxin in our digestive tract, which is highly dangerous and problematic. So we see a crossover to the bacteria in our guts with genetically modified corn. What's the danger of us eating meat with unpredictable genetic defects? That's completely ignored. And Health Canada says we're ignoring that in our discussion paper. Well, that's the main known risk. Another big risk is that cloned animals are more sickly. So those that actually will live to be adults, they tend to need more hormones, they tend to need more antibiotics, they tend to need more veterinary attention, which will include higher chemical drug use. Now, you could argue that it's already a problem that we have too many hormones, too many antibiotics, too many drugs in our naturally bred farm animals. Don't you think you would study the risk